Let's go to section 2, chemical reactions. Chemical changes are also called chemical reactions, and the chemical reactions are represented by chemical equations. A chemical equation shows the formula of the substances that we have at the beginning and the formula of the substances that we have at the end. Substances at the beginning are called reactants, and substances at the end are called products. How can this happen? How can we have different substances at the beginning and at the end? Because the reactants break the bonds between their atoms and new bonds are formed to get the products. Let's see this picture in your book. Here we have a representation of hydrogen chloride and sodium hydroxide. So what happens? First, these molecules meet, they knock together, they hit each other, and they break the bonds between sodium and oxygen and hydrogen and hydrogen and chlorine. Hydrogen, chlorine, oxygen, hydrogen, and sodium. Then new bonds form. So sodium goes with chlorine together and we get salt. And then oxygen and hydrogen with the other hydrogen go together and get water, and we get water. So in the end, the substances are different from the substances at the beginning. Let's see another example, which is on page 148 of your workbook. In this case, we have the reaction of carbon plus oxygen to get carbon dioxide. This is a very simple reaction. The reactants are carbon and oxygen, and the product, because it's just one product, is carbon dioxide. What happens here is oxygen breaks the bond between the oxygen atoms, and then new bond between carbon and these oxygen atoms is made. Remember that molecules were representing like this. So if this is broken, carbon can go there and we get this new molecule. Okay? Let's see another example. It's a reaction between hydrogen and oxygen. We have molecules of hydrogen and a molecule of oxygen. These molecules break the bond between the two atoms of oxygen, and then hydrogen breaks also the bonds between the hydrogen atoms. Its oxygen atom get one and one hydrogen, but separately, okay, not together. And we get molecules of water. We represent chemical changes by chemical equations like this. For example, this is a chemical equation and a chemical equation. Next week, we will explain why we write these numbers in front of the formula. Okay? We will do it next week. One more thing to finish is that many times we add state symbols. What are state symbols? Letters that stand for the state of the substance. S for solid, G for gas, L for liquid, or AQ for aqueous solution. So, for example, in this equation, solid carbon, gas oxygen give us gas carbon dioxide. Hydrogen is a gas, oxygen is a gas, but we get water, which is a liquid. Okay, so these symbols mean the state of matter in which the substance is.